This video is on electron configurations. I'll be going through how to start them from the very beginning, and we're going to be doing them in the long form. Later on, there will be a video on how to do them in a shorter way. So in order to follow along and do some of the stuff in this video, you will need your periodic table to do this, so make sure you get it out right now. Pause if you need to. And what we have to start with here is what we call the Aufbau or the diagonal rule. So quantum numbers, remember, tell you the energy level, and we've got our sublevels here, and we're going to say how many electrons fit in each one. So what I've done is, and you have this on your paper, they're listed out in rows for each energy level. So in the first energy level, you can only have an s orbital. So that's why it says 1s. 1 is the energy level, s is the sublevel. So in the second energy level, you can have S and P. So that's why we've got them separately, the 2S, and you've also got a 2P. Why do you get P in the second, not the first? Because the second energy level has more space. It's bigger. The third energy level, you can have SP and D, and the fourth SPD and F, or for SPD and F, and 5, 6, and 7 all have SPD and F. So we need to fill electrons in order from lowest energy to highest. So that is the Aufbau rule, or the diagonal rule. So why don't you write that down? Oops, sorry. Go back to here. So can fill sublevels only starting at the lowest energy. Okay, so that would be 1s. So we're always going to start there and work our way up. Why would they go in the lowest energy first? It's because it's easiest. So it's not as simple as going in order like 1s, 2s, 2p, 3s, 3p, like in order across the rows, like you would read a paper. This is the diagonal rule, which means we're going to follow these diagonal lines. So why don't you draw these lines in, like I have on your paper, and I'll show you how to follow them. So we start with right up here. So here's our starting point. So we start with 1s, and if you follow the arrow down, that would be our first energy level and our first orbital. So if I was listing out the energy levels in orbit, I would start off with 1s. Okay. S orbitals can hold 2 electrons. So then I write a little 2 as a superscript up above. So that's the number of electrons. Okay, so 1 is my energy level. Oops. The S is the sublevel, and the 2 is the number of electrons. Okay, so then I have to go to the next energy level if I have more electrons than 2. So after that, I come down here, then I go to the next diagonal. So then I go to here. So I start here and I go through. So the next one is 2s. So I write 2s. Notice how I write them right next to each other. There's not a space, there's not a comma. S, still an S, it doesn't matter which energy level it's in, can hold 2 electrons. So I put a 2 there. Okay, so after that, what comes next? So then I go to the next diagonal line, and I start up here. So then it comes 2p, and then after that, 3s. So I write 2p, and p sublevels, remember how that has 3 orientations, 3 orbitals? 2 electrons can fit in each orbital, so 3 times 2 is 6. After 2p, I said was 3s. It's an S, so it can hold 2. Okay, so now I keep going. What comes after that? Well, I go to the next line. Comes 3p and then 4s. So 3p, p holds 6, and then 4s. 4s2. Then we go to the next line. 3d, 4p, 5s. So we've got 3d next. D's have, remember, 5 orbitals, 2 electrons in each for a total of 10. And then 4p. 4p6, and then 5s2. Okay, the common mistake that kids they make is right here. Well, they'll go through and they'll do 3p here, and then when you're reading across, they'll do 3d next. But actually, 4s is lower energy, so electrons are going to go there before they're going to go in 3d, which is higher energy. Okay, so follow the diagonals. Don't just go across left to right. Okay, so after 5s comes 4d. Let me fix this so we can see it all. So 5s comes 4d. D's have 10. I'm going to have to go down to my next line. And then we get to 5p and 6s. So 5p, 6, and then 6s, 2. And then we go to our next line, and we've got 4f. So here's our first f. 4f. And F has 7 orbitals, 2 electrons in each. 7 times 2 is 14. So it can hold 14 electrons. It's a lot bigger. After 4s comes 5d. So 5d, 10. Then we've got 6p, 6, and then 7s, 2. And then 5f, 14. 6d, 10. 7p, 6. And then we've got 6f, 14, 7d, 10, and 7f, 14. Now, we're not going to write any electron configurations that have things beyond, let's see, what do we stop at? 6d, I guess 7p is going to be our last one. We don't have anything beyond this because we don't know any electrons beyond that. Any atoms, sorry, beyond that, any elements. So this is how we write out where all the electrons are in an atom. So let's do this with a couple examples, and hopefully it'll make more sense. So we'll use our periodic table. We're going to start with just hydrogen. So the very first element. So in order to do this, we need to know how many electrons hydrogen has. None of these have charges, so they are the same as the protons, which is the atomic number. So I look up hydrogen, and hydrogen has 1 electron if it's neutral, which it does here. So it has 1 electron. So we need to say where that 1 electron is. So we start with the lowest energy level, which is 1s. And s can hold 2 electrons, but we only have 1. So we're going to write that hydrogen's 1 electron is in the first energy level, it's in an s sublevel, and it's only 1 electron. So that's hydrogen's electron configuration. Okay, let's do helium. Helium over here has 2 electrons. So, again, we start off with the first energy level, always the lowest, S sublevel. It has 2 electrons, well, S can hold 2. So there's helium's electron configuration. Okay? So let's do chlorine next. So chlorine now has 17. Okay, so we're going to go beyond the first energy level. So 17 electrons. So we start off with 1s. Can hold 2 of the 17 electrons. We have 15 more. Well, where do they go? So we go in order. So what comes after 1s? 2s. So 2s can hold 2 electrons. So there's 4 of our electrons. We still have 13 more. So what comes after 2s? Where's it going to go? Well, then it's going to go into 2p. So we've got 2p. P can hold 6. Okay, so we've got 10 total now electrons. We're listed where they are. We have 7 more though. So what comes after 2p? Follow the diagonal to 3s. So I write 3s. S can hold 2. Okay, so now we've got 5 more to do. So I go back. Well, where do they go? What comes after 3s? 3p when you follow the diagonals. So 3p. Now 3p can hold 6 maximum. It can hold less though also. So we want to get 17. So 2 plus 2 plus 6 plus 2. If you add those up, you get 12. Okay? To get to 17, we need 5 more. Okay? Plus 5 equals 17. P can hold a maximum of 6, but we only have 5, so I'm going to write 3p5. This is the electron configuration for chlorine. Okay, let's try iron together. Iron has 26 electrons. So I'll start out at the beginning, and I can follow chlorines for a while. So I'm going to have 2 in 1s. Oops, how many did I say? 26. Then 2 of them are going to go in 2s, 2s2. Then I'm going to go 2p6. And then we've got 3s2. And then comes 3p, and I'm going to fill it up now because I'm going past that. I have more electrons. So now I have 18. So I have to get to 26. So what comes after 3p? Not 3d, Remember what I said? You have to follow the diagonal. It comes 4s. So we've got 4s2. Then comes, if you follow the diagonals, 3d. And so I said this is, let's see, 6 was 18, so 2 more is 20. So we're at 20 right here total if you add them up. Okay, and we want to go to 26. D can hold 10, so, but we only have 6 more. So those 6 go in the 3D. Why don't you pause the video right now and try TA. It is number 73. All right, for TA, you should have 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, scroll down, 4d10, 5p6, 6s2, 4f, 14, and 5d3. If you add up all of those superscripts, all of these numbers, you should get 73. The learning check, well, this one will be done in class because you couldn't type this very easily into Moodle.